Hi, boys and girls. Mrs. Roach here. Welcome back for part 2 of lesson 2, Phases of the Moon. And so I hope you watched the first part of the lesson. And so now we are going to continue right now, the lesson. All right. Okay, so here are our objectives. And I already introduced them in the first part. And so we have the same objectives for part 2. So I'm going to slide over this. Okay, so here are the rest of our vocabulary words for lesson 2 that we're going to talk about in this section of the video. And so we have tide, which is the regular rise and fall of the water level along a shoreline, solar eclipse and lunar eclipse. And we're going to be talking about both of these eclipses and how they are different and when they occur. Okay, so we will be reading about both and learning about both eclipses as well as tides. Okay, the first vocab word we're going to read about is tides, okay? And we're going to read this paragraph, and I want you to think of this question as we're reading. What causes Earth's tides? And some of you maybe already have an idea of what the answer is to this from lesson 1. And so you might be already able to answer this. Let's read this together. It says, the moon has a gravitational pull on Earth. As Earth rotates, the strongest pull moves across the surface of the planet. Rocks and soil do not move easily, so we do not notice the pull on land. In the oceans and large lakes, the water flows as gravity pulls on it. This pull causes tides, a regular rise and fall in the level of the water. And so what causes tides? Can you look back in the paragraph and find the answer to this question? Good. I hope you're able to find that the gravitational pull of the moon on Earth's ocean's water causes its tides. So very good. All right, so now that we know what causes tides, let's talk about two different types of tides. There is a high tide on the left screen, and in the same area, there is a low tide. Okay, and so every day, boys and girls, there are 2 high tides and 2 low tides. All right, so if you ever head to the beach, if you've ever been to the Jersey Shore or the Delaware beaches and you've gone for a beach day, when you get there in the morning and it's high tide, there is nowhere to sit on the beach because the water is all the way up close to the opening of the beach. And so, beach space is limited when it is high tide. And then later on in the day, you'll see that the water goes back out, and that we call low tide. And that is when it appears like there's much more beach area, more sand for you to sit. And so there are 2 low tides and 2 high tides every day. Okay, and we're going to read about why that is. All right. So here is a diagram on the right, okay, showing you how the moon is orbiting and how that the gravitational pull is causing the tides. And so read along with me, and we're going to find out, why are there low tides and high tides, and be able to answer that. So if you'd like, you can pause and read independently, or you can read along with me. Okay, water bulges up on the side of Earth facing the moon. It also bulges on the side opposite the moon. This is because gravity pulls stronger on the whole Earth than on the water farthest from the moon. So here are the bulges that they're talking about, okay? And it says, as Earth rotates, these bulges move across the ocean. The water rises compared to land twice each day. These rises are known as high tides. On the parts of the planet that are at right angles to the moon, the water is low compared to land. This is known as a low tide. There are 2 high tides and 2 low tides each day. Okay, so here you can see in the diagram. And so we know that the moon has an effect on Earth's tides, but does the sun also affect the tides? Well, we're going to read this paragraph right here and find out if the sun also affects Earth's tides. Okay, so read along or pause and read to yourself. The sun also affects tides, but not as much as the moon. When the sun, the moon, and Earth are in a straight line, high tides are higher than usual. This is called a spring tide. So here you have the spring tides, which are higher than usual. When the sun, the moon, and Earth are arranged like an L, the high tides are lower than usual. These are called neap tides. Spring tides and neap tides occur twice each month. So not daily, but twice a month. Whereas the two low tides and the two high tides occur daily, the two normal low and high tides. All right, we are going to watch a quick demonstration showing what causes high tides on opposite sides of the Earth. So please watch this video.
Hi, this video is called Dance of the Tides, and it's going to explain why we have a high tide not just on the moon side of the Earth, but also on the far side, the side furthest from the moon. In our demonstration, we have one person who's going to be the moon, one person who's going to be the Earth, and two people who represent the ocean on either side of the Earth. Tides on Earth are caused by the gravitational attraction of the moon, and secondarily, the sun. The water on the moon side of the Earth is going to be the most attracted and pulled the most toward the moon. The Earth itself is also attracted toward the moon, and the water on the other side is also attracted, but less so, because distance matters so much in this model. So now we see the water stretched out in space with a tidal bulge on each side of the Earth lined up with the moon. So when our Earth rotates through 24 hours, we get a high tide on the moon side of the Earth, a low tide about 6 hours later, another high tide, and then 6 hours later, another low tide. So through 24 hours, the Earth rotates under two tidal bulges that represent high tides, and then also two low tides. And the moon is the main influence on our tides.
All right. So we just learned about how the moon is our main influence. And we're going to answer some questions from our Be a Scientist notebook. So why are two high and two low tides? Why are there two high tides and two low tides every day? I want you to think about that question and try to respond in your notebook. Okay, if you were able to conclude that the water bulges on the side of Earth facing and opposite the moon are the reason for the high and low tides. As Earth rotates, these bulges move across the ocean. The water rises compared to land, which is the high tide. And then on the parts of the planet not facing the moon or opposite the moon, the water is low compared to land, or low tide. So if you were able to write down any of those key ideas, you are correct. And so we also learned about how the sun does have an effect on the tides. But why do the sun and the moon both contribute to tides? Think about it. Well, if you were able to conclude the moon affects the tides because of gravity, but gravity from the sun and the spinning of the Earth also changes how the tides behave. So very good. All right, we're going to move on and we're going to talk about eclipses. We're going to talk about two eclipses today, solar and lunar eclipses. First, let's read. You're probably asking yourself, well, what is an eclipse? Let's read and find out. Sometimes the sun, the moon, and Earth form a straight line. If the moon is between the Earth and sun, the moon blocks sunlight. When the shadow of the moon falls on Earth's surface, a solar eclipse occurs. Okay. During an eclipse, part or all of the sun may be blocked from view. So that is what an eclipse is during an eclipse. And so here you have a diagram of the moon, okay? The sun, the moon, and the earth are forming a straight line. And we're going to talk about a solar eclipse, okay? This is showing you a solar eclipse. We had a very rare solar eclipse in 2017. If you can remember that, you were probably about 8 years old, 7 or 8 at the time. And this was rare because it was called a total eclipse, meaning the sun was totally blocked from Earth. And that, boys and girls, happens on average about 375 years, every 375 years. So we will not see one here where we're located in a very, very long time again. And so if you did not see the total solar eclipse in 2017, I'm going to show you this short video clip from the state of Idaho where they experienced the total solar eclipse. And just a warning, there's a lot of screaming because they're very excited because it's a rare event. So I'll try to turn the volume down, but please take a look at this total solar eclipse. Okay. And so what you just saw, boys and girls, I'm going to go back here for a minute. What you just saw was a total solar eclipse. And so we won't see that for a very long time, but we will see different types of solar eclipses where the sun is not fully blocked. And so the next eclipse, solar eclipse, is actually in 2024. So in about 4 years from now, a little bit less, you'll be able to see the next solar eclipse. All right. So we're going to move on, and we're now going to talk about lunar eclipses. Okay. So let's read and see what a lunar eclipse is. It says, if Earth is between the sun and the moon, the shadow of Earth blocks sunlight from reaching the moon. Then a lunar eclipse occurs. If the moon is in deep shadow, it may disappear for a short time. During a lunar eclipse, the moon often looks dim and red. This happens when the moon is in a partial shadow called the penumbra. Okay, so here is our diagram down below. Okay, here you have the penumbra or the partial shadow where the moon is. And so this is where you see this happens for a short time as well, just like the solar eclipse. And the shadow of Earth, okay, is blocking the sunlight. And so this is when a lunar eclipse occurs. All right, we're going to watch another short video about explaining the lunar eclipse. So please watch.
If you looked at the moon over the course of a few weeks, you'd probably notice that it looks slightly different every day. The change in its shadow is based on where the moon is in its orbit. We call this cycle the phases of the moon, and it occurs roughly once a month. At least twice a year, however, something quite different happens. The moon passes through the shadow cast by the Earth, causing it to look extremely unusual for a short period of time. From the Earth, the moon will appear to darken and turn a deep red before eventually returning to normal. This is called a lunar eclipse. If we were to look at what happens from space during an eclipse, it would go something like this. First, the moon passes through what's called the penumbra, where the sun's light is only partially obscured. This results in only a slight darkening of the moon. As the moon continues along its path, however, it enters what's called the umbra, where all direct light from the sun is blocked. But if the sun is blocked, why does the moon turn red? When light from the sun goes by the side of the Earth, it passes through a long and thick layer of Earth's atmosphere. Shorter wavelengths of sunlight, like blue, are scattered by the atmosphere, so by the time the light has finished its trip to the moon, more of the longer wavelengths, like red, are left over. On the Earth, the same thing happens at sunset as the ground you stand on gradually passes into night. As the eclipse ends, the moon leaves the umbra, returns to its normal color, and then leaves the penumbra, brightening and resuming its original cycle. Overall, the whole process lasts only from a few minutes to a few hours, so you'll have to be quick if you want to see it. But, as long as you're willing to stay awake, you'll catch the moon as you won't see it too often.
Okay. So as you saw on the video clip, lunar eclipse, appears to be that reddish orange color when it is occurring. And so this happens every, 3 years or so. And so you may have experienced one before. So here is a live clip of a lunar eclipse. I believe this is in Spain. So I just want to show you this. Okay. And so as you saw, boys and girls, lunar eclipses are, that reddish orange color, and they are more commonly seen. And that's because the Earth casts a larger shadow during a lunar eclipse than a solar eclipse. And so, a lunar eclipse will occur in the next 2 to 3 years. So please be on the lookout for one. All right. We are going to wrap up what we learned about solar and lunar eclipses with these 2 questions. And so the 2 questions say, when does a solar eclipse occur? And when does a lunar eclipse occur? So if you can think back to what we just learned, when does a solar eclipse occur? Good. A solar eclipse occurs when the moon is directly between the sun, Earth, and casts a shadow on Earth. Very good. Okay, and so when does a lunar eclipse occur? Very good. A lunar eclipse occurs when Earth is directly between the sun and the moon passes through Earth's shadow. Very good job. All right, so that brings us to our essential question for lesson 2 to wrap up lesson 2. So what causes the repeating pattern of the moon's appearance? I hope you were able to conclude that the moon revolves around the Earth about every 29 days. During this cycle, we see different amounts of the lighted side of the moon in a repeating pattern. And so that wraps up everything we learned about in lesson 2. We are going to return to our Paige Keeley, okay? And let's take a look at our Paige Keeley, and I want to ask you, has your thinking changed? I want you to think about that, and if so, how? And so here are all the examples of things that you should have put an X on because they can be predicted by regular patterns of the moon. So lunar eclipses, moon phases, tides, solar eclipses, and the position of the moon in the sky are all things that can be predicted by regular patterns of the moon. And so you may have changed your thinking at the end of this lesson, which is a good thing. All right. And so that wraps up lesson 2, boys and girls. And here's another lovely corny joke that I know you love. What did Earth say to the other planets? Whoops, you guys have no life. So there are more corny jokes where that came from for next week. And I would like to make sure, I'm going to try and turn my camera on that I don't know if I'll be able to do that. Okay, that's all right. So boys and girls, please make sure that you are doing the assignments, and assignment 9 goes with both parts of this video lesson. And so I will see you boys and girls next week. Take care. Bye-bye.